Okay, the first problem asks you to solve the equation A equals I R squared L plus C. So we write that equation. A equals I squared L plus C. And we figure out what it's going to take to eliminate everything but R on one side. Now, since we're solving for R, I'm going to write this thing in reverse order, just switch the sides, write pi R squared L plus C equals A. So we can kind of focus on R, and we'll have it on the left side, which is where we usually want it. Not necessary to do that, but it's helpful when you're first encountering this. Okay, so the first thing we have to do is eliminate something on the left-hand side. Of course, it's going to appear on the right-hand side. The pi R squared L is a set of multiplications. Plus C is an addition. So we're going to take care of addition before we take care of any multiplications, meaning that we're going to add negative C to both sides. So if we write down the equation negative C equals negative C below the original equation, we see that the C minus C subtracts away and it leaves us zeros. We just end up with R squared L on the left side. On the right-hand side, we have A minus C. And now we're starting to get somewhere. Also, the C that I'm writing on the right, for some reason, must come out smaller than the C on the left. We want to be sure that we're not seeing a capital C and a lowercase c, because they would be different variables. Capital and lowercase letters stand for different variables. Okay, anyhow, when we subtract C from both sides, we end up with pi R squared L equals A minus C. Now, how are we going to get to R? Well, the first thing we want to do is do something about that pi and the L. The pi and the L are both multiplied by R, so we can take the pi R squared L and divide it by pi L. And then, of course, we have to do it on the right-hand side. The right-hand side has A minus C, so we'll write A minus C as a numerator of a fraction, and we'll write pi L as a denominator. So what I have now is pi R squared L over pi L is a fraction, A minus C over pi L. Those two are equal. Okay, well then, pi is a factor of the numerator and a factor of the denominator, so it'll divide itself out. And L is a factor of the denominator and the numerator. It'll divide itself out and just leave us R squared. That's equal to A minus C over pi L, which is the same as the right-hand side in the preceding step. Okay, now we have R squared equals A minus C over pi L. How are we going to get R? Well, this is a little bit of a curveball. We haven't really talked, I don't think, about square roots, but I decided to do it anyway. If you get it down to here on this quiz, R squared equals A minus C over pi L, and don't know what to do after that, that's full credit, because it'd be unfair for me to expect you to know what the next step is, but I'm going to show you what the next step is. Okay. The solution to R squared equals something is R equals square root of that something, or the negative square root of that something. Okay, because if you square the square root of A minus C over pi L, you get just plain old A minus C over pi L. If you square negative square root of A minus C over pi L, Well, you're multiplying a negative by a negative, you're still going to get a positive, a minus c over pi l. So there are two solutions when you have a square equal to something. That's something that will come up, so I decided to go ahead and do a little preliminary work with that. Okay. Now, let's look at the inequality x minus 2 greater than or equal to 9. Well, this is a very easy inequality to solve. We add 2 equals, add the equation 2 equals 2 to the inequality x minus 2 greater than or equal to 9, and we end up with x equals 11. And we can check that. If x is 11, we get 11 minus 2 is, I said it wrong. We end up with x greater than or equal to 11. Okay, so let's try that again. Check that. If x equals 11, x minus 2 is 9. 11 minus 2 is 9. If x is bigger than 11, then x minus 2 is going to be bigger than 9. Okay, very simply, we can see that. We can plot the solution. On a number line. Let's just put x equals 11 here. Now, I've drawn a number line. I've drawn a little dotted vertical line and labeled through the number line, labeled it x equals 11, so that where that vertical line meets the horizontal x-axis, we have a point. We put a circle around that point because that's where the solution starts. Now, the solution is x greater than or equal to 11, so I'm going to fill in that dot. So that 11 is included, then I draw everything to the right. Hopefully that makes sense. It's a fairly simple inequality. Just for demonstration, let's try the inequality 2x plus 5 greater than or equal to if we add the equation negative 5 equals negative 5 to this inequality, we get 2x I'm going to change the problem just to illustrate what I intended to illustrate. Changing the inequality now to 2x plus 12 greater than or equal to 4. Then I'm going to subtract 12 from both sides. I'll write the equation negative 12 equals negative 12 below the original inequality. And when I add these, the 2x plus 12 minus 12 that we get from adding the left-hand sides just becomes 2x because 12 minus 12 is 0. And four and the negative 12 gives us negative 8. Now, this still doesn't illustrate what I intended to illustrate. I'm sorry. My brain is, for no good reason, I'm going to change the problem slightly. Instead of 2x plus 12 greater than or equal to 4, I'm going to make the equation negative 2x plus 12 greater than or equal to 4. Now, the step that I made is still valid, except that when I add the negative 12 to both sides, I end up with negative 2x greater than or equal to negative 8. And I hope that's not confusing. Again, the original inequality is negative 2x plus 12 greater than or equal to 4. Solving this, want to get that 12 away from the x. So I add the equation negative 12 equals negative 12, which gives me the equation negative 2x greater than or equal to negative 8. Then we divide both sides by the coefficient of x. That would be negative 2. So we're going to get negative 2x over negative 2 on one side and 8 over negative 2 on the other. The inequality reverses because we're dividing by a negative. So instead of greater than or equal to negative 8, we get negative 2x over 2 is less than or equal to negative 8 over negative 2. The result being that so x is less than or equal to 4. Dividing negative 2x by negative 2 gives us x. Dividing negative 8 by negative 2 gives us 4. And we've reversed the inequality. And we can sketch that inequality. Draw on a number line. I've got a little dotted line, vertical dotted line through the horizontal number line to indicate x equals 4. And put a circle around x equals 4. Fill it in. Draw an arrow to the left. So I've represented x less than or equal to negative 4 on my picture. Okay. And I think everybody's going to be all right with this. But be sure you remember about reversing the inequality when you multiply or divide by a negative. Adding or subtracting a negative doesn't do anything to the sign, but multiplying or dividing by a negative reverses the sign of the inequality. We'll also do absolute value of x minus 2 equals 9. Have we done this in here? I've done it in 2 other classes, so I could be confused. I kind of think we have, and I should have checked, but here we are. Okay, anyhow, the absolute value of x minus 2 is just the magnitude of the number you get when you do x minus 2. We don't know if that magnitude is going to be positive or negative. So we break this inequality into 2 parts. X minus 2 equals 9, or x minus 2 equals negative 9. Now again, if x minus 2 equals negative 9, then that does satisfy the inequality. X minus 2 equals negative 9, so the absolute value of x minus 2 is 9. So if x minus 2 equals negative 9, the absolute value of x minus 2 is 9. And if x minus 2 equals 9, then the absolute value of x minus 2 is clearly 9. So we break this inequality into 2 cases. And then we solve the equations. X minus 2 equals 9. Well, I'm not going to write out all the details. I'm just going to say the solution is x equals 11. The solution of x minus 2 equals negative 9. We'd add 2 to both sides. We get x equals negative 7. Then we go back to the inequality and we plug x equals 11 in. Now, it's the absolute value of x minus 2. If x equals 11, that's the absolute value of 11 minus 2, which is the absolute value of 9, and that's 9. Now, the equation is absolute value of x minus 2 equals 9, and we just got 9 equals 9 by plugging in x equals 11. If we plug in x equals negative 7, we get absolute value of 7 minus 2 equals 9. Well, 7 minus 2, negative 7 minus 2 is negative 9. So we have absolute value of negative 9 equals 9, and the absolute value of negative 9 is 9, so we get 9 equals 9. So we've satisfied the inequality. Okay, now we move on to graphing. And I've just asked everybody to plot points. Now I've drawn a rectangle. So it's pretty much a square on the board, but any rectangle will do. Okay. And I've got a left edge and a right edge. I've drawn a dotted line extending the left edge a little bit and labeled it x equals -10. A dotted line extending the right edge a bit. Now, the left edge is vertical, the right edge is vertical. And on the dotted line that extends the right edge, I've got x equals 10. So that from left to right, this rectangle represents numbers from -10 to 10. Okay. Then on the lower edge, I've extended it and labeled it y equals -10. In the upper edge, I've extended to y equals 10. Now, both of those edges are horizontal, perpendicular to the vertical edges. So we have the line y equals -10 at the lower edge and the line y equals 10 at the upper edge. In the middle, the horizontal line goes through the middle. This rectangle I've labeled y equals 0 because 0 is exactly halfway between -10 and 10. And the vertical line I've drawn a vertical line through the middle, and it's then halfway between x equals -10 and x equals 10. That's at x equals 0. That's as much of a grid as you really need to use to sketch the 3 points I've specified. Okay? You're not going to sketch them with incredible accuracy, and if you need incredible accuracy, then go get yourself a grid. You print grid paper off the internet, you buy a block of grid paper, or, in open math, they give you a grid and ask you to use the mouse to plot the points. I think that's okay, but I think that plotting points by hand and actually writing out, drawing out a grid, just a simple grid of appropriate dimensions, maybe the same dimensions as the one you see in open math, drawing out that grid, labeling the lines, and putting the points where you think they ought to go is a better exercise than clicking the mouse in 3 places. Okay? But you can do both. It doesn't take long to do either one. I use these simplified grids because with a little practice, you can draw one in 10 seconds. 20 seconds if you're pretty slow, 30 seconds if you're really slow. Still, it's not a big chunk of time, and it's worth the effort. Okay, in any case, I've got this grid. I want to plot the points -4, 7, -1, -4, and 3, 6. Well, the point -4, 7, I'm going to say, let's find the line x equals -4. It's not totally necessary to do this, but it's helpful. Okay, now x equals -4 is between 0 and -10, a little bit closer to 0. So I'm going to draw a line that's a little bit closer to the x equals 0 line than the x equals -10 line. That's a vertical line. Now, labeling this line is optional because it still helps just to take 2 seconds and sketch that line. Okay, and then we want the y-coordinate to be 7. And the x-coordinate's -4, the y-coordinate is 7. So 7 is between 0 and 10, closer to 10 than 0. So I'm going to say y equals 7 on a line. I probably got a little bit too close to y equals 10, but it's a plausible line, y equals 7. It's closer to the y equals 10 line than it is to the y equals 0 line. And I'm going to put a little X there where those 2 lines intersect. And that's my point, -4, 7. Then we want -1, -4. Well, and when I labeled this line x equals 4, that was wrong. It's x equals -4. Okay. Now the point -1, -4, we want x equal -1. Well, -1 is going to be between 0 and -4 and much closer to 0. So I'm going to draw x equals -1. About here, a vertical line that's 4 times closer to x equals 0 than my x equals -4 line. 10 times closer to 0 than my x equals -10 line. Now, actually, I don't think I got it quite close enough, but I'm not brave enough to go any closer because my lines aren't perfectly straight and I'm afraid they're going to hit each other. Okay, actually, I could have done better than that, but the point is, as long as these are in reasonably the right position, make them as well as you can. As long as they're reasonably right position, if something like this occurs on a test, and it might well, I'm not going to penalize it. Okay. Now, if you got the -4, 7 point down near y equals -10, then I'm going to say, nah, if you got the other 2 points right, I'll probably give you most of your credit, but I'll complain a little bit. I'll point out your error. I don't really complain. Okay. But make them reasonably right. Okay. And okay, so -1, -4, working -1, -4. We got the line for x equals -1. We want the line for for y equals -4. Well, -4 is between 0 and -10, almost halfway, but not quite. So I'm going to draw y equals -4 here. And then where the x equals -1 and y equals -4 line intersect, I draw a point. Now, I will say everybody's paper that I looked like had perfectly good points. I just took one glance. I'm just looking for something up here, something down here, and something up here. Okay, in a reasonable position. So everybody knows what they're doing here. But again, we want to cover this as completely as possible. Okay, so we have the point 3, 6. Means x equals 3, y equals 6. Well, x equals 3 is between 0 and 10, about a third of the way between from 0 to 10. So I'm going to say x equals 3 here. And then y equals 6. Well, y equals 6 is just below y equals 7. And then at the intersection of the x equals 3 and y equals 6 line, I draw a point. Now, I go into all this detail about the x equals 4 line and the y equals 6 line and all that stuff because by the time people get to the end of the chapter where they've got to graph things, they still don't know that x equals 5 is a vertical line. Okay? So I want to emphasize that. And that's in a pre-calculus class where people should have known that for a long time. And so we want to kind of emphasize these little glitches that impede people when they're trying to learn the pre-calculus or any other math course that relies on graphing. Another thing that I'll do, and this is just a preliminary, if I ask you to draw a smooth curve through these 3 points, could you do it? A smooth curve through your 3 points. I'm going to stop a minute. I'm going to ask you just draw what you think is a smooth curve that goes through all 3 points. There are many, many ways that could be done. Now, I haven't defined what I mean by smooth. So if you've got 3 points in approximately the same relative positions as on the graph, a smooth curve is not going to do this. It's not going to consist of 2 straight lines because down here on the lowest point, I've done a straight line from the leftmost point to the point next to the, going from left to right. I've drawn a line from the first point to the second, a straight line, and then a straight line from the second to the third. And I've got something that looks sort of dangerous. If you sharpen it, it could be a serious weapon. Okay, that's not smooth. Now, serious weapons can be smooth. You know, an axe blade is smooth. That's even worse than a pike or a knife. Okay, so we don't draw straight lines. We don't connect our graph points by straight lines. Okay, so I'm going to sort of erase that. It's going to mess things up a little because it's not a perfect eraser. So another way I could do this, I kind of like this one. It's pretty hard. Nope, got a little sharp there. Okay. Okay. Now what I've drawn is a smooth curve. Looks a little bit like an octopus head tilted to the side, but it dips down, comes through the first point, goes up, turns around, and smoothly goes through the third point, the rightmost point, and then comes back down below, then up through the second point. Okay, that's a smooth curve, and that would satisfy my question. Okay, now the way to draw the graph of a function, we haven't defined what a function is, but to draw the graph of a function, we're going to go a smooth curve from left to right. Okay, we go through the point furthest to the left, the point next to the right, and the point furthest to the right. And probably the easiest way to do this is just to come down here and then come back up. I kind of missed my second point. And it's just kind of a U shape. And these, about half the class drew one like that. Okay. Now, there's nothing wrong with what anybody did, as long as you didn't have a corner. If you had a corner, you know better now. Okay. So it's going to be important later on to know what a smooth curve is. It's worth a couple of minutes to establish that now, so it won't surprise you later when you see it in another course. You're actually going to see it in this course too. So, all right. So that wasn't part of the quiz, but everybody got the 3 points right, and I'm not just happy, I'm ecstatic. Okay. And everybody got the last problem. Now here I want you to plot the points 0, 8, and 5, 0. I've drawn a grid. The grid starts at x equals 0. I have the vertical line x equals 0. That's going to be correspond to the left edge of my rectangle. And I just put x equals 10 at the right edge. I had reasons for wanting to use 10 rather than something. But any two numbers, I could have used 0 and 5, because the x values are 0 and 5. There's no other x values. A lot of times you want to leave yourself room to extend the graph, though. So I left myself a little room to extend the graph. Okay. Now, vertical line down through the center, that's halfway between x equals 0 and x equals 10. That's at x equals 5. And then my y values. I've got y equals negative 10 and y equals 10. Y equals negative 10 for the lower edge, y equals 10 for the upper edge. Then the point 0, 8 is going to go on the x equals 0 line. And the y equals 8 line will be between y equals 0 and y equals 10, quite a bit closer to y equals 10. This is about where I saw it on everybody's paper. Almost wrote 10 there. Okay, there's the y equals 8 line, and where the y equals 8 line intersects the y equals 0 line, we have a point. And then 5, 0. Well, in drawing the center lines and label them, I gave you that one for free, right? Where x equals 5 meets the line y equals 0, we have the point 5, 0. And then I asked to sketch a straight line through these points. Oh, I can't even blame that on the chalk. I don't know why I got that far off. Okay. Now there's a straight line that goes through the points. And I took the line all the way from, well, I extended the line until it reached the boundary, until it reached a boundary of my rectangle. Okay. That's something you kind of want to think in terms of doing. So anybody want to tell me what the x coordinate of the point is? You have to tell me by holding up fingers. What's the x coordinate of the point where that line leaves the rectangle? These figures. What's the x coordinate of this point? Okay, nobody's. Oh yeah. Are you? Is that a greeting or? It's 10. All the fingers on both hands. Okay, either it's defensive, or you know. Okay, here's the line x equals 10. The right edge of the rectangle is x equals 10. And I think everybody's picture, if extended, would hit the right edge of the rectangle. If the line was a little steeper, it could hit the low edge. Okay. If you got the line a little too steep, maybe you would hit the low edge. It's okay. That's an estimate. Just got to know you could hit one edge. There are 4 edges. Eventually, you're going to hit one of them. Okay. Then you can estimate the coordinates. Okay. And if this is, if the right edge is the line x equals 10, then when the line reaches the right edge, that is at the point x equals 10, and you want the y coordinate, so you estimate the y coordinate. Now, if I draw this and make an honest estimate, this is a little further from the low edge than, okay, the point where I hit the right edge is a little further from the lower edge than the original point 0.8 is from the upper edge. So I'm going to say y equals -7 at that point. Now we're going to see that that's incorrect because I'm building up to the next topic, okay? And also, a simple geometric argument tells you that there's a lot of symmetry in this thing. And since the line goes through the middle, it's got to hit the right edge as far from that edge as the first point was from the upper edge. And I think I said that wrong. Anyhow, that doesn't matter because we're going to proceed to get an equation for this line. Now, one other thing I'm going to do is I'm going to extend this line just a little further. Now, we've already hit the left edge, and we don't go past the left edge unless we have a real good reason and unless we think we can do it accurately. So I'm going to use a different color here. And I'm going to extend the line. What I'm going to write is I extend the line to the y equals -10 point. I've got the dotted line for y equals -10, goes right through the lower edge. So I can see that the graph extends just a little bit, not all that far. And we hit a point here. Now, how far do you think it is from the x equals 10 line to this point that I just marked on the lower edge? Show me with your fingers. In one hand, okay? What do you think? How far is it from here to here? If this is x equals 0, x equals 5, x equals 10, how far is that? Okay, yeah, you started with 2 and then you said 3. And okay, so about half the class said 3, half the class said 2. And I was thinking, it's about 2 or 3. Okay, close enough. The estimated coordinates of that point, well, we know that y equals -10, and we know that x is 2 or 3 more than 10. So let's just say x is about 12.5 there. Now, a little more emphasis, I'm going to sketch a little vertical line here. I'm going to say that is x equals 12.5 with a question mark. So that the coordinates would be x is 12.5, y is -10. Okay, now we're going to go ahead and develop an equation for this line. But first, we're going to do something else. Here we want the slope of the line through the point 0, 8 and 5, 0. Okay. So I'm just going to isolate those. I'm just going to draw a point here and call it 0, 8. I don't need a rectangle. I don't need a grid. Point I'll call 0, 8, and then a point I'll call 5, 0. I could do it on my grid, especially if I had a bigger graph. It'd be easy enough to do. Okay, now let me just ask a question here. You can answer verbally because you can't spell it out with your fingers. Actually, probably could, but I wouldn't be able to read it. Okay, so the question I'm going to ask is, when you say slope, there are two words that ought to pop into your head. Now, if it's been more than a decade or two since you had your math class, those words might be gone if you haven't used them. It might still be there. And if you had it recently, well, maybe those words were used, and maybe they weren't. Okay, you probably had a formula. And the formula is easy to remember, and there's nothing wrong with the formula, except that formula doesn't have any meaning unless you know what it means, which is kind of a tautological statement. Okay, anyhow, what two words pop into your head when I say slope? Okay. Well, very good, very good. I immediately got rise over run. And it came immediately from somebody who had the course at least a couple decades ago. Okay. And everybody else, agreed, they recognized it. So slope is rise over run. Okay. Now I'm going to draw a path from the first point to the second point. Okay. Now the simplest path I can draw is a straight line from that point to that point. I want to draw another path using an arrow, because you see I've got an arrow running from this point to this point. Okay, I want to draw another path with two arrows, one of which is parallel to the x-axis and one of which is parallel to the y-axis. I'm going to ask you to do that. I'm going to give you just a minute to do it because my experience in pre-calculus classes, it's hard for some people to process verbal instructions. And it's harder for me to process verbal instructions, although I can do it pretty well, than to dig something out of a textbook. It's just a matter of learning style and auditory versus visual and all kinds of other stuff that I don't even begin to understand. So can you sketch a horizontal and a vertical arrow, starts at the left point, goes to the right point? Okay. Yeah, I had to give most people a little bit of help, but everybody understands. Okay. Okay, now notice that with incredible intelligence and foresight, I labeled these things so that I could go this way or this way. Okay. And that's probably the most foresightful thing I've done all semester. Anyhow, because it's very easy. I do it all the time to label things and right where something else is going to go through it. It's just something to keep in mind. I'm not going to penalize it as long as I can read everything, because I'd have to penalize myself every day. Okay. Okay, so there are two ways to do it. Okay. I can go horizontally up to the point where I'm above the 0.50, and then vertically to the 0.50. So I've started at 0.8. I've got an arrow going straight to the right until it's directly above 0.50. And I could have drawn a vertical arrow. I can draw. Four dotted lines here to indicate the coordinates, right? I drew the line x equals 0 through the 0.08. I didn't label it. And also the line y equals 8. So those two lines are perpendicular to each other. One's vertical, one's horizontal. They both go through the 0.08. And then I've drawn two lines through 50, one vertical and one horizontal. The vertical line will be x equals 5. The horizontal line is y equals 0. They could be labeled, and I might well label them, but they can be helpful because it just takes a second to draw four dotted lines. If you want to make your picture really accurate, which is not absolutely necessary, if it makes you feel good to have an accurate picture, go ahead. Okay. Some people like to have things done nice and neat. Okay. Some people like me that put them down as long as it represents what it's supposed to represent. Well, I've formed two triangles here, haven't I? Okay. Now let me check the time. Okay, we're doing okay. Let's take the two blue lines. Those are the two lines. The line when I started at 0.8 and moved horizontally. And then the line where I started at the end of that arrow and moved vertically down to 5.0. Okay. Now let's take the horizontal arrow. Is that the rise or is that the run? Just say, if it's the rise, thumb up. If it's the run, thumb down. What do you think? Rise or the run? Well, that's going to be the run because rise goes up and down, right? And this one just goes horizontally. So whether you got that or not, this one I'll label the run. Now, I'd like to label rise right here, but my coordinates 5.0 are in the way, just illustrating what I said before. However, I can write rise a little bit higher, still horizontally across from the arrow. So the horizontal arrow represents the run, the vertical arrow represents the rise. Now, the run is an arrow. How long is that arrow? Can you show me with your fingers how long the run arrow is? How long is the run arrow? Tell. I'll explain it. Okay, it's okay. Okay. Well, the run goes from the x equals 0 line to the x equals 5 line, doesn't it? Now, how far is it from the x equals 0 line to the x equals 5 line? It's clearly 5. So I do kind of recommend drawing and labeling the x and y arrows for 2 points if you're trying to find the slope. Okay. Now I'm going to write the calculation. Run equals 5 minus 0. We're going from 0 to 5. If we do 5 minus 0, we get 5, and we're going in the positive direction. We're going from 0 toward 5. That's a positively directed arrow. We have to subtract where we start from where we end. So it's finish minus start. That makes sense? Very important. And now rise is what? Well, the second point is at the y equals 0 line. First point is at the y equals 8 line. So how far is it? It's 8 units, but it's going to be -8 because it's going down. And of course, if we do the calculation, subtracting where we start from where we end it at y equals 0, we start at y equals 8. So the rise is 0 minus 8, which is -8. If we do where we end minus where we start, it automatically tells us whether we're going up or down. Okay? So now, slope equals rise over run, which is -8 over 5. And I would leave it as a fraction. Although if you want to write it as -1.6, as long as you've written -8 over 5 equals 1.6, negative 1.6. Okay, it equals negative 1.6. There's your slope. Well, the slope is how steep the line is, and is it going up or is it going down? Slope is negative, so the line's going down, but you can see in your original graph, that's exactly what the line does. Okay? Let's see, we've got about 11 minutes, which will be enough time to confuse you thoroughly. I suppose it would be enough time to confuse you thoroughly, but I'm going to try not to do that. Okay, but this next step is a little bit of a jump. Okay, we see the graph. Our line has slope. Negative 8/5. Now, I'd love to develop a theory of why the equation of a straight line is what it is. The equation of a straight line is mx plus b. Where m is the slope, and b is the y-intercept. Now, there are other forms of the equation of a straight line, but this is the one we're going to sort of concentrate on. You see other forms in the open math. Okay. Y equals mx plus b, where m is the slope and b is the y-intercept. So what do we know about this line? We know the slope, right? So y equals negative 8/5 x plus b. We still don't know b, but actually we do. The y-axis is the line x equals 0. So if we wanted to draw the x and the y-axis on our original picture, we take our line x equals 0 at the left edge of our original rectangle. Draw an arrow straight up, going at least above our rectangle, and label that the y-axis. And of course, it goes down below the rectangle as well. And the line y equals, oops. Well, that was a bonehead error. Started to put my y-axis in the lower edge, which is not where it goes, because the lower edge is y equals negative 10, right? Y equals 0 is the line, horizontal line goes through the middle of our rectangle, as you recall. So I'm going to just draw that arrow and call that the x-axis. The y-intercept is where the line intercepts the y-axis. Okay? It's at the point 0, 8. X equals 0, y equals 8. So B equals 8. It looked like an 8. Looks like a really ugly 8. Okay? B equals 8. And now we know what the equation of the line is. The line is therefore y equals negative 8/5 x plus 8. Now let me ask the question. For what value of x is y equal to negative 10? Okay, the response I got was, well, didn't we estimate 12.5? Yeah, but that was just an estimate. We were going to test our estimate. Remember, the estimate was drawn on a diagram that was maybe 6 inches by 6 inches with chalk that doesn't cooperate all that well, okay? By me. There are a lot of reasons it might be inaccurate. If you measure all the lines, when I say this line's halfway between these two lines, I'm off by a little bit, inevitably. My vertical lines aren't even necessarily all that vertical. Okay? Yeah, the same's going to be true of you unless you use draftsman's tools. And you don't want to take the time to do that. You want to be able to slop down a graph that represents everything and make estimates, try to do it reasonably accurately. So we have an estimate of negative 12 would be the answer to this question, right? But how can we find what the actual line through 0, 8 and 5, 0, at what x coordinate that line goes through y equals negative 10? More call for suggestion. Yeah. Okay, typically I won't get an answer to this. Occasionally I do. Well, all we have to do is take that negative 10 and put it there where y is. We just substitute negative 10 for y. And I think some of you were suspecting that from, looks in your faces, people slapping your foreheads, people, oh, yeah. Okay. And if you didn't, that's okay. But we substitute negative 10 for y. In the equation, and we get negative 10 equals negative 8/5 x plus 8. Okay? That's an equation we can solve for x. Now I'm going to give you a great gift that nobody ever takes. There's a 5 in the denominator here. Is anybody really enthusiastic about working with fractions? Most people aren't. Now, if you were educated back in my era or close to it, you're comfortable with fractions if you've done it since then. But most people aren't because our educational system doesn't require it very much. Multiply both sides by 5. Why? Watch what happens. I do 5 times negative 10 equals 5 times negative 8/5 x plus 8. Okay? 5 times the left-hand side, 5 times the whole blame right-hand side, not just part of it. Because you only multiply 5 by part of it, you throw off the balance. The left-hand side would no longer be equal to the right. Okay, 5 times negative 10 is negative 50. Then I'm going to write out 5 times negative this x plus 5 times 8. That gives us negative 50 equals negative 8x, because the 5 in the denominator divides the 5 that we're multiplying by, which is going to be in the numerator. It leaves us negative 8x plus 40. Now that's an easy equation to solve. It's as easy as the other equations you've already solved. So we're short on time, we're kind of out of time. But if I solve this, oh Lord, I didn't know this was going to happen. I had negative 40 to both sides. Never mind, it didn't happen. I had negative 40 to both sides. I get negative 8x equals negative 90. You get x equals negative 90 over negative 8, which is negative 10, 125 if you like. Actually, that's negative 10.25. It's negative 10 and a quarter. So this tells us that our estimate, negative 12.5, wasn't accurate. So when we estimated this thing goes through negative 12.5, we weren't accurate. We weren't completely accurate. We weren't miles off. But the reason we weren't completely accurate is because this rectangle isn't drawn all that carefully. And the line should have hit the x equals 10 point at a different value of y that we could easily find by letting x equal 10. And we would then find that y would equal negative 8. But we're out of time. I was hoping to do the whole thing, but that's enough. If you understand that chunk, you have a good overview, a good introduction to linear equations, so you'll be able to do the homework. Open Math will tell you a few things. I'll give you some formulas that I haven't given you. And we'll talk about those formulas next time. I want you to start with a picture though. Okay?